telescopes on Earth have enhanced our view of the stars by collecting more light than our eyes can see. President Biden recently introduced the first publicly shown image from the James Webb Space Telescope. In the realm of space research, the James Webb Space Telescope stands head and shoulders above the competition due to its incomprehensible design and origins. Webb is exploring the mysteries of our solar system, other planets orbiting distant stars, and our place in the universe. A star, 120 light-years away from Earth, was the target of a recent experiment using the Webb telescope. Astronomers are still puzzling over the potential presence of carbon-based molecules in the atmosphere of a planet that is believed to have water. This discovery opens exciting possibilities for potentially habitable worlds and offers a fascinating look at a planet unlike anything in our solar system. Welcome to Lab 360, let the adventure begin. If you want to stay up to date on all the latest space news, don't forget to subscribe. Exoplanet K2-18b, which is 8.6 times Earth's mass, has been studied by NASA's James Webb Space Telescope. Carbon-bearing substances, including methane and carbon dioxide, have been discovered, supporting previous studies. K2-18b may be a high aquatic exoplanet, meaning its surface is covered with water and its atmosphere is rich in hydrogen. Our understanding of this system has been transformed since initial observations from NASA's Hubble Space Telescope revealed the atmospheric features of this exoplanet in the habitable zone. K2-18b, located 120 light-years from Earth in the constellation Leo, orbits a cold, dwarf star, and has no similar surrounding planets. Exoplanets like K2-18b, whose diameters are between Earth's and Neptune's, are unique in our solar system. Astronomers remain divided over the characteristics of these sub-Neptunes, as there is still much we don't know about their atmospheres. Some scientists believe that exoplanets in this region provide ideal conditions for looking for signs of life, making K2-18b an intriguing target. The lack of ammonia and the abundance of carbon dioxide and methane lend credibility to the idea that K2-18b has a water ocean beneath its hydrogen-rich atmosphere. Dimethyl sulfide, a molecule only produced by living organisms on Earth, has also been detected in the exoplanet's atmosphere. On Earth, plant life in oceans is responsible for releasing large amounts of dimethyl sulfide into the atmosphere. However, dimethyl sulfide's detection on K2-18b is still tentative, and further evidence is needed, according to a scientist from the University of Cambridge. Future Webb investigations may confirm whether dimethyl sulfide is present in detectable amounts in K2-18b's atmosphere. Even though K2-18b has carbon-bearing molecules and lies in the habitable zone, this doesn't necessarily mean it can support life. K2-18b's radius is 2.6 times that of Earth, and it is believed to have a massive, high-pressure core like Neptune but with a thinner atmosphere rich in hydrogen and an ocean surface. For high aquatic worlds, vast bodies of water are expected, but it's also possible that the water is too hot to sustain life or even remain in a liquid state. We have obtained the most detailed spectrum of a habitable zone sub-Neptune to date, commented Subhajit Sadar of Cardiff University, a part of the research team. Light propagation from K2-18b's parent star through its atmosphere allowed for this examination. Since K2-18b is a transiting exoplanet, its luminosity dims as it passes in front of its home star. NASA's K2 mission discovered the exoplanet during transits, with a tiny fraction of sunlight passing through the exoplanet's atmosphere and reaching space observatories like Webb. As light travels through the exoplanet's atmosphere, it leaves behind traces that scientists can analyze to determine the composition of the gases. The research team plans to continue using the mid-infrared instrument spectrograph on the Webb telescope to further study K2-18b. They hope these future studies will confirm their findings and provide new insights into K2-18b's climate. The discovery of life on a habitable exoplanet would revolutionize our perception of our role in the cosmos, according to Madhusudan's conclusions. Water has been detected in other locations by the Webb telescope as well. In a faraway galaxy, complex chemical compounds resembling smoke or haze were discovered by astronomers using Webb's instruments. This pushes back the record for such detections by nearly an extra billion years, making it the oldest known example of complex organic molecules identified in the cosmos. These findings at the cosmos periphery are both exciting and, for some, terrifying. Let me explain why this groundbreaking discovery alters our understanding. An early galaxy, originating around 10% of the universe's current age, has these components. Polycyclic aromatic hydrocarbons, carbon-based compounds, are present in smog, coal deposits, and oil on Earth. But why is this discovery so significant? The molecules we discovered are not simple, like water or carbon dioxide, says lead astronomer Justin Spilker. These are huge, complex molecules, containing hundreds or even thousands of atoms, not easily formed so soon after the Big Bang. It's astounding that such complex molecules have been detected so early in the universe's history. The light detected by scientists began its journey just over 1.5 billion years after the Big Bang, in a universe that's approximately 13.8 billion years old. We are witnessing the primordial era of the universe's development. The catch is that, thanks to Webb, we've pushed the previous record back by about an additional billion years, allowing us to detect these complex organic molecules. What if we could go further back in time? Would we find even more of these molecules? If we did, our cosmological models and scientific understanding would be profoundly affected. Earlier attempts to identify complex organic molecules in distant galaxies could only confirm their presence. Now, thanks to Webb's sensitivity, we can distinguish finer details, such as the precise location of these molecules within a galaxy. In the early galaxy SPT 041888, the concentration of these chemicals is not uniform, and we don't yet know why. This discovery also provides more evidence that galaxies were forming much earlier in the cosmos than previously believed. Despite being only a tenth as old as our Milky Way, this galaxy was already as large and had produced as much carbon and oxygen as our own. The vastness and complexity of the universe are truly astonishing. As a species, we continue to venture forth into the unknown, armed with knowledge and a deep curiosity to understand. With each new discovery, we get closer to unraveling the mysteries of the stars. A fresh light on the cosmos is emerging, thanks to Webb's impressive capabilities. If you enjoyed this, don't forget to click the like button and leave a comment. We explore together, so make sure to subscribe to Lab 360 and hit that notification